Okay, so when it comes to chapter 5, one of the things you are probably going to notice when I start opening up my notes is we are not actually going on to 5.3 next. We skip over 5.3, we come back to it. Because 5.3 and 5.5 and 5.6 are all very similar. Those are when we get to the proofs. Before we get to the proofs, we're going to talk about 5.4. The book decides they go better out of order, and I disagree with them. So, open up to page 9. It's section 5.4. Today we're talking about specific types of triangles. Specifically equilateral and isosceles triangles. What is a triangle that is equilateral? What's that mean? All three sides are the same. What's it mean to be isosceles? Two sides are the same. So, with this, we get some things that we know about angles and sides in triangles. Specifically, there's our base angles theorem, which if you're wanting to add things to your postulate sheet as we go through them, it's not a bad idea. This is on the top of the back side of your postulate sheet. The base angle theorem states that if two sides of a triangle are congruent, then the angles opposite are congruent. In other words, I got this triangle right here. If two sides are congruent, do you see some congruent sides in that picture? Yeah. What are their names? AB, BC. If AB is congruent to BC, if I have a pair of congruent sides in a triangle, I also have a pair of congruent angles. They're the angles opposite of those sides. This side is not touching what angle? Angle C, which means that is the angle opposite of it. Angle C is congruent to, now look at the other side. The other congruent side was BC. Which angle was it not touching? A. Angle C is congruent to angle A. We also have the converse of that theorem. The converse is the reverse. It flips, flops the if and the then. And the converse of the base angle theorem then says if there are congruent angles, there are also congruent sides. I was given that angle D was congruent to angle F in this picture. The sides across from them are also then congruent. Across from this angle is this side. Because angle D does not touch side EF. Angle F does not touch side ED. Essentially, if you see an isosceles triangle, if you see a triangle that has congruent sides or congruent angles, it's going to have both. The picture essentially always looks something like that. The angle between the two congruent sides is not the congruent angle. The side between the congruent angles is not a congruent side. We can use this information to help us solve things. So, solve for x is what the problem asks us to do. Starts off really, really basic. The key thing is paying attention to the right things. What do you notice about this triangle? For congruencies, look at those. What does it say are congruent? Got a pair of angles. And if it's got a pair of congruent angles, it also has a pair of congruent sides. But which ones? Look at the side between them. Which side is between these two? The one marked with what? 13? That's not the congruent one. The between is not the congruent. Those two are congruent. What's x?
11.
Ta-da.
Wait.
These are congruent. X and 11 have to be the same. Now question B has an equilateral triangle. I can tell that because it's got 3 congruent sides. Now we didn't talk about something with 3 congruent sides.
So it would be x equals 60 or no?
But it works the same way. If it's equilateral, if it's got 3 congruent sides, it has 3 congruent angles. You tell me, Jesus, does that mean x is equal to 60?
Sure.
Yes. Now they do get more challenging than that, but those were 2 just to kind of get us started. And then they're going to start getting a little harder. Okay, question C. I see I've got some congruent sides. If I have some congruent sides, I also have some congruent angles. The x, the 40, or the unmarked one? Which are the 2 that are congruent?
The 15 and the 40.
15 is not an angle.
I mean,
Which angle is between, start by looking at the angle between them. Which angle is between those 2? The x, that's not the congruent one. The between is not the congruent, which means it must be this one and this one. That one's not marked. If that one's not marked with anything, I now have information to mark it with something though. These 2 are congruent. What's that mean as the measure of that angle? 40. Do you notice that you now have 3 angles in the triangle marked? What do you know about the 3 angles of a triangle? Add up to 180. X plus the 40 plus the 40 better be equal to 180. Add those up, we get 80. X is equal to 100. Now they're going to switch back and forth about how you approach these problems because it's all about making sure you're paying attention to which angles and which sides you have. You know nothing about what sides add up to. The only time you're ever going to do adding things up is if you're working with angles and it has to be all 3 angles in the triangle. Okay. Question D. What does it have marked as congruent? All the angles. If all the angles are congruent, what do you know about the sides? They are also all congruent. Gives me this, that means this. Do you notice that x is in 2 different places? Is it going to be the same thing in both places? Yes, which means I can choose any 2 places to work with stuff. What's the easiest equation to write if all 3 of these things are equal? X equals 6. That's the most complicated of the 3 sides. If I only need 2 sides to be equal, just choose 2 of them. The 2 least complicated. Had I chosen that one, it should have still told me x was 6. I just would have had more work involved. Question E. I have 2 congruent sides, which means I must have 2 congruent angles. Again, the one between them is not the congruent one. Which angle is between the 2 congruent sides? The 40. That's not the congruent one. These are. If I'm ever marking something as congruent to something without a marking, the one without a marking gets whatever the marked one is. In other words, I'm putting what right here? X. It's congruent to x.
x equals x.
But can you solve an equation x equals x? No. You can't solve an equation a number equal to itself or a variable equal to itself. It's angles. Do you know something about all three angles? There's an x, and there's a 40, and the three angles of a triangle add up to 180. Combine my like terms, x plus x is 2x. Subtract 40. It's 140. Divide by 2. X is 70. Now sometimes it's going to give you a slightly different notation of doing the same thing. Look at question F. Do you notice that above it says measure of angle 2 is equal to 7x plus 15?
Yeah.
It's just because it's hard in this picture to write 7x plus 15 in that corner and make it look like it's in that corner. That's why they do that sometimes. The process is still the same. What's it showing you is congruent.
43.
Yeah, it's showing you the sides are congruent. So that side's 43, but x is not on a side. So it's not helpful. X is in the angles. If I have two congruent sides, I have how many congruent angles? 2. The one with the 71, the one with the 2, or the one with the unmarked? Which one is not congruent? The unmarked, because that's between them, which means these two are congruent. There's something on each of them, which means you set them equal, but do not set 71 equal to 2. 2 is not the degree measure. What is the degree measure of that angle? 7x plus 15. Subtract 15 and 7x is equal to 56. Divide by 7 and x is 8. I'm going to do just one more on this page. We're going to look at G and then we're going to flip on to the back side. The picture shows congruent angles. Sorry, no, let me try that again. The picture shows congruent sides, which means it has congruent angles. Lincoln, head up, please. Two congruent sides means two congruent angles. Mohammed, are you paying attention up here? Which angle is not the congruent one? The not congruent one is the one between the two congruent sides. The sides here, 92 is between them. Those two are the congruent. X plus 55 equals x? No. You can't add an x to a problem that x already is on.
Put 2 on the side in the middle, that's a 180.
Can I put 2 over here as well?
Yeah.
indicating that this angle is x plus 55, and so is this one. Now I have all three angles marked. The three angles of a triangle still add up to 180. X plus 55 plus an additional x plus 55 plus an additional 92 equals 180. X plus x is 2x, 55 plus 55 plus 92. 202. Subtract 202. Get negative 22. Divide, and x is? Negative 11. Is x allowed to be negative? Yes, as long as it doesn't make negative angles or negative side lengths, it can be negative. If I were to plug that back in, I'd get 44 for an angle measure. Is 44 negative? No, then we're fine. We're going to skip over H and I. We've done problems like those already. In fact, we're going to skip over quite a few of them. We're going to do A, and then we're going to talk about D, E, and F, because those ones are a little different. We've done one like A, but I just want to make sure that we're getting practice on one more with sides, because sides tends to be the ones that people make the most mistakes on, because they mix up which sides they mark as congruent, or they start adding them all up. Do you know what all the sides of a triangle add up to? No. 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 If you are answering me, the answer is no. Do you know what they add up to?
No.
No. Triangle sides add up to, technically, if you answered perimeter, then you would be right. No one answered perimeter. You do not have a single number that side lengths of a triangle add up to. There is no such sum that they always add up to. So you cannot add up sides unless you're looking for perimeter. Are we looking for perimeter? No. To solve for sides, you have to set side lengths equal. You just got to make sure it's the correct side lengths. Which, there's two angles here that are congruent, which means there's two sides. Which side is not the congruent one?
The top?
None.
The one that is not congruent is the one that's between. Just like with the sides going to the angles. The angle between congruent sides is not congruent. The side between congruent angles is not congruent. This angle, what side's between them? 2x minus 2. That is not the congruent one. Those are the congruent ones. Once you know they're congruent, you set them equal, you solve. That part I have zero doubt in my mind. You could solve an equation. Don't get me wrong. Some of y'all make mistakes every once in a while, but I know you know how to solve. You can use this property on more and more complex problems as you go, though, which is where D, E, and F come in. There's two triangles here. There are two isosceles triangles here. Because those are congruent, and these are congruent. Two congruent sides meets two congruent angles. These two sides are congruent.
Yes.
Which two angles? I'm going to call this 1, I'm going to call this 2, I'm going to call this 3. 1 and 3. Angle 2 is between the congruent sides, so this is congruent to this. Neither of them's marked with anything though. And you cannot call it x because x is already used in the problem. So we have to find something else that'll help us. That's when we go to the other triangle. These two sides are congruent. I'm going to call this angle 1, I'm going to call this angle 2, and then we got the 51.
51.
This is the angle between, so this is congruent to this. So I know that this is 51 degrees. How does knowing that's 51 degrees help me with the other triangle?
Because
You can plug it back here, because the V8 there.
Do we have vertical angles?
Yeah.
Do you see an X and the angles across from one another? So not only are these two congruent to these two congruent, but all 4 of them are actually congruent to one another. This is 51 and this is 51. Did that help me solve for X? It helped, but did it get me X? No. X is hanging out in this angle. But I know all 3 angles in that triangle, and the 3 angles in a triangle add up to
180.
180. Combine like terms, we get x plus 185 equals 180. Subtract the 185 and x is -5. Pair of congruent sides on that triangle, pair of congruent sides on this triangle. 2 congruent sides leads to 2 congruent angles, and it's those 2 because the 30 is between. 2 congruent sides leads to 2 congruent angles. That one and that one. What did you notice, Jesus?
Little box there.
There's a little box in the corner. What's that mean? We got a 90-degree angle here. This part of it's 30. How do I find that part of it? This part. If this thing's 90 and this part's 30,
Minus 90.
90 minus 30, because they have to add up to 90, that's a 60-degree angle. And that 60-degree angle is congruent to the angle marked with 2. Final problem. Problem F. see two triangles. Technically, I see a third triangle, but I'm not going to use that one. This triangle has 3 congruent angles, which means it has how many congruent sides? 3. That helps me find y. What's y? 4. Okay. X is hanging out over here on LM, so let's go to that triangle now. It's got 2 congruent angles, which means it has 2 congruent sides. Which 2? The x plus 1 and
The other one.
NL.
Yes.
Do you notice that NL already has a single tick mark?
Yes.
Which means when I mark this one congruent, should I put a double tick mark or a single tick mark? Single. Which means all 4 of these are congruent. Which means I can say x plus 1 is equal to what? 4. X is equal to 3. Congruent sides leads to congruent angles. Only in triangles. It doesn't work for bigger shapes. But it's nice for triangles. Guess what? I got a worksheet for you. So, that was 5.4. Worksheet is due on Friday. 5.1, worksheet 1 is due today. What's happening tomorrow? Quiz. So, do not wait until Friday to get the practice on today's stuff because it is on tomorrow's quiz.